Hey, welcome to section 3.4. In this section, we're going to be talking about the library of functions. Mostly we're just going to go over functions that show up all the time. So we'll discuss the most common functions that you'll see. You'll see these functions in this class, in all subsequent math classes you take, and probably any other class that even uses math or functions. One of these functions will arise. So these are the functions that it's important to know their properties of and know what the graphs look like. We'll start with the simplest case. It's just the constant function f of x equals b. Means you plug in a number and you get the same output no matter what you plug in. So for instance, if we have f of x equals 1, that tells us that f of 1 equals 1, f of 2 equals 1, f of pi equals 1. Anything we plug in, we just get 1. And the graph looks something like this, or well, it looks exactly like this, where it's just a straight line across at 1. So that one's pretty simple. A slightly more complicated version is the identity function. The idea is you plug in a number and you get that same number back. So the function doesn't do anything. So we have f of x equals x. So f of 1 is 1. F of pi is pi. F of 1/2 plus 1/3 is 1/2 plus 1/3. And if you think about it, we can already see that this is basically the slope-intercept form. We plug in 1, we get 1 out. 2, we get 2 out. 3, we get 3 out. 4, we get 4 out. So it just follows this line. We then have the square function. The square function says you plug something in and you square it. So I'll stick with writing in black. So f of 1 equals 1 squared, or 1. F of -2 equals -2 squared, or 4, and so on. It's pretty straightforward. This is our classic parabola, like that. And then we'll remember that this is also an even function. It's even since f of -x equals -x squared, which equals x squared, which equals f of x. So that tells us we have symmetry across the y-axis. So on the y-axis, it looks exactly the same. So our graph looks something like that. We have our absolute value function. Again, this is going to look exactly like how you would expect. It's going to look like the graph of an absolute value function. And it functions in the way that you expect. F of -1 is 1. F of 1 is 1, because we're just taking the absolute value of whatever you plug in. So our graph looks like the identity function on the right-hand side, because we plug in a positive number, we get that same number back. So this looks like identity function. And on the opposite side, we can actually check that this is an even function. And you should pause the video right now and check that it's an even function. And that would mean that the left-hand side just looks like a reflection of the right-hand side of the graph. The square root function, again, tells us that if we just plug in a number, we just take the square root. So f of 3 is the square root of 3, which is fine, even though we don't have like a rational approximation for it. F of 4 is 2. And for this case, we're just taking the positive square root. That's what's going to make it a function. Think about what would go wrong if we could have the positive or negative value come out. And so if we draw a graph, it looks something like this. And we can also find that by just plotting points. And what about on the left-hand side? Take a second to pause the video and think about what the left-hand side of the graph is going to look like. All right, hopefully you came up with that we can't have anything for the left-hand side because we can't plug in a negative number to this function. F of -1 is the square root of -1, which is not a real number. So the domain of this function is just 0 to infinity. So we can't plug in any negative numbers in. And therefore the graph is only on the right-hand side of the plane. And then we finally have the reciprocal function. Tells you that if you plug in a number, you're just going to do 1 over that number. So f of 2 is a half. F of 3 is a third. And if we're plugging in fractions, all we have to do is just flip them. So f of 1/2 is 2. F of 1/5 is 5. So as we graph small values, we're very large. And as we graph larger values, we get small. And we can also check that this is an odd function. And so just knowing that it's an odd function means that you should be able to tell me exactly what the graph looks like on the other side. Nonetheless, we'll draw this line. And because it's an odd function, we know that we just have to rotate it 180 degrees. So it looks something like that, where it should look exactly the same, just rotated 180 degrees. All right, that's all we're going to do for this video. In the next video, we're going to move into piecewise defined functions.